So, to summarize this, there are three things that can happen when you square root a number. Most of the time when you square root a number, you get an answer that's smaller. Like square root of 9 is 3. 3 is smaller than 9. Square root of 4 is 2. 2 is smaller than 4. Okay? Sometimes, and these will be very important points, you can square root a number and get the same thing you started with. Like the square root of 1 is 1 and the square root of 0 is 0. Those are going to be really important, especially when we square root graphs. And very rarely, because you hardly ever see that, is that if you put a number between 0 and 1, it can't be equal to 0 because equal to 0 is exactly the same. It can't be equal to 1 because square rooting 1 is exactly the same. But anytime you take a number between 0 and 1, when you square root it, you actually get an answer that's bigger than you started with. The square root of 1/4 is 1/2. 1/2 is bigger than 1/4. So we're going to see how this affects a graph. And you can turn to page 83. And what we're going to be looking at is radical functions where we can square root any graph we already know how to graph. So we're going to look at the square root of any f of x that we already know and see what happens. We've already done the square root of x. But what we're going to do with our other graphs is learn a new technique. And I'm going to start with the square root of x as our example. So, square root of x, well, x, if I draw it in a blue line here, y equals x, that's just a straight line. When you square root a function, wherever it's 0 and 1, those points stay the same. So over top of this in green, I'm going to take 0, 0 and 1, 1. I'm also going to highlight those 2 points on my graph here. You notice that you had 0, 0 and 1, 1 on your square root graph too, because they're exactly the same. Then it's pretty obvious when you square root something, like here I'd have 4, 4, but when I square root 4, I get 4, 2. That's that point. Obviously, that's below my original graph because square rooting after 1 makes it smaller. But in between 0 and 1, our graph has to be slightly above, because if you square root anything in between 0 and 1, it's going to be bigger. So we see here, if I look at my original graph, y equals x, if I graph the inside on its own, I notice when I square root that 0 and 1 stay the same. Because when you square root 0 and you square root 1, it stays the same. Anytime my y values were between, right, here's my y values between 0 and 1, notice the green graph is slightly above my original graph. Because square rooting a number between 0 and 1 produces a result that's a little bit bigger. And then anywhere where my original graph was bigger than 1, square rooting makes it smaller. So my green graph is below my blue graph. And we're going to use this as our strategy for graphing things with square roots. Now, when you had, here we'll look at this one and then we'll quickly look at the next one. Like, if you had been asked to graph y equals the square root of x plus 4, I would probably say right now transformations is easier. You know your square root graph? Do you see that this plus 4 would move it 4 to the left? But now, if you graph the inside first, and you plotted where it was equal to 0 and 1, and made it slightly above and below, you would get the same graph with a different strategy. Sometimes this different strategy is actually even better, and I think that shows up with our next example here. Okay? Why is this a good one to use the new strategy? Well, graphing negative x plus 2 has a y-intercept of 2 and a slope of negative 1. Graphing that red line would be easy. Why is this one harder in transformations? What does the negative do? Horizontal or vertical reflection? Horizontal reflection. What does the 2 do? Horizontal or vertical translation? Horizontal. 2 units to the, right? You see that you normally want to say left, right? Right, left, wrong, here, what? This would be one that you'd have to remember to factor
Hi,
out.
could I have Arinda to the office for a moment, please?
Yeah, no problem.
Thank you.
So you'd have to write it in factored form first before you did your transformations. Now, you can just graph the inside. Plot the 2 points that are equal to 0, where the y value is 0 and 1. Those are going to be the same. When the y values are between 0 and 1, you're slightly above. And afterwards, you're below. Because I would take a point like, oh, here, y is 4. What's the square root of 4? 2. That's really easy to find out a point. If you can graph the inside function, you just need to square root those y values. And using the 3 important things, sometimes they're less, most of the time they're less. Sometimes they're the same. These are like our starting points. Find these same points first. But sometimes it's slightly bigger. And that's when x is between, when you square root something between 0 and 1. And what are we square rooting? We're square rooting our y values. So we look for our y values between 0 and 1. We make them slightly bigger. And what this allows us to do is we can now graph anything, right? And if you want to highlight here, they've said these same things we've been saying, okay? 0 and 1, they're called invariant points. They do not change. That's the first thing you're going to look for. Second point here, and maybe I'll highlight it, and I'll make a note. Right? If your original y values are between 0 and 1, so I'll write 0 less than y less than 1, the graph is above. Next, this one, I'll write a note, I'll change colors. If your y values are bigger than 1, the graph is below. And I didn't actually talk very much about this one. This is very important though. You already know that you can't square root a negative number. So if your original graph, and I'll go back to one that we just did here, like my original graph here, all my y values are negative. Notice your square root graph doesn't keep going, it stops, because you can't square root a negative. So anytime your graph has negative y values, your square root graph won't exist. So if y is less than 0, you can't square root a negative, that won't exist. So when we go to example 1, what they're going to do is say, here's some graphs. Can you square root a graph? And remembering these 3 things, 0 and 1 are the same. Between 0 and 1, slightly above. Bigger than 1, it's going to be below. You're going to be able to graph this. So the first thing I would do is I look at this graph. And I would say, is my my y value ever 0? Yes, right there. Here's my y value is 1. Does that ever happen on my graph? Yes, right there. Next thing I would probably do in a question like this is look for numbers I can square root really easily. Like, you know the square root of 4 is 2. Is my y value ever 4? Oh yes, it's right there, so I can put that dot. Square root of 9 is 3. Is there ever a y value of 9? Yes, right there, so I'm going to go straight down from that and mark 3. When your y values are between 0 and 1, it has to be slightly above, okay? And here is where we can make some tiny little mistakes that we don't want to. Okay? I will show you slightly above, that's correct. There we go, that is correct. I will now show you some slightly aboves that are bad. It is bad to go back in time. I mean, that's really exaggerated, but you could lose a half a mark for doing that. Do you see how my graph goes back in time? Like, it doesn't exist when it's less than this, and my graph went behind that. So we don't want to exaggerate slightly above. This also is an exaggeration of slight, oh, that one went back in time. You can't go above a 1. So in slightly above, sometimes the best you can do is almost draw right on top of the line. As long as you're just a little bit above it, you're going to be fine. But you don't want to exaggerate it so you go back in time or above 1. And then, of course, I've got these other points, so I can just connect them there and get my square root graph. It's that easy. Okay? So, I want to square root the second graph. I look for y values of 0. Yes. I look for y values of 1. Yes. I look any points that I could do. Well, I guess you see that if you extended this, you would get 4 there. So square root of 4, I would have 2 there. Between 0 and 1, slightly above. No problem. Connect to the other point. And we are done. Now for both of these, they want us to do domain and range. So there's the domain and range for both of those. And you can circle question number 5.